So now we're going to be graphing exponential functions, and they are very similar to what we did to growth and decay. We still have our, let me change my pen, plus 0 right here because there's nothing there. That's going to be our k. We have no h because there's nothing being added or subtracted to the x. We're still going to identify our asymptote, which is our k. So our asymptote is going to be y equals 0. So we have right here a y equals 0. We have our asymptote. Then we can still pick the same kind of points that we picked before. You can pick -1, 0, 1, or for these I usually like to just pick 0 and 1. And our 0 and 1 are our x values. And when we substitute it inside, remember our function that we're substituting is e to the x. So e to the 0 power is just 1. E to the 1 is e, and we know from the previous slide that e is approximately 2.71. So if we graph that, we're going to have 0 and 1. We have 1 point there. At 1, we have around 2.71, which would be somewhere around there approximately. And when we graph it, we're going to get something that looks like this. And just like growth and decay functions, our domain is still going to be all real numbers. So x is limited to real numbers. And our range, it's again going to be based on where our asymptote is at. So since all our values are above this asymptote, so it's going to be greater than that. So we're going to have y is an element of the reals such that y is greater than 0. So for this one, it's basically the same thing, but I'm asking you to identify parts of the equation of your exponential function. So we know that our a is -2. Our h is -1 because it's going to be the opposite of our h. And our k is -3. It's going to be the same. So we know that our asymptote is going to be -3. So at -3, we have our asymptote, which is right here. We also know it's going to be all real numbers. That's not going to change. And our range is going to be y is element of reals such that y is going to be, in this case, is going to be less than -3. And the reason that's that is because our a is negative. That means our graph should be it should look something like this. It's kind of like when we did quadratics, and if your leading coefficient was negative, it was basically flipped over the x-axis. In this case, it's going to be flipped over your asymptote. So we do the same thing. We're going to do a t-table. We're going to get better at these t-tables. And 0 and 1, and we're going to use this as our main function, and then our vertical and horizontal shift, which are the +1 and the -3, we'll do after these points. So we're going to have -2 e to the 0, which is just going to be -2. -2 e to the 1, that is -2 times positive 2.71, which it would be approximately -5.42. Okay, and now we're going to do our shift. So for our x values, we're going to do the opposite of +1, so we're going to subtract 1. And for our y values, we're going to do the same, so we're going to subtract 3. So that means our new values that we're going to graph with the horizontal and vertical shifts are going to be -1, -5, and 0, -8.42. So when we graph those, you're going to see that it's under your axis of symmetry. So we're going to have -1 and -5 right there, and 0 and 8.42, so somewhere there. So we're going to have something that looks like this as our exponential function. Okay, so we're going to do the same thing. It's exactly like the other one. It's just now our a is 5. Our h is going to be +3 because it's the opposite, and our k is going to be 1. Our asymptote is going to be 1, so at +1, we have our asymptote. We're going to have still the domain is going to be x element of the reals, and y is going to be y's element of reals, such that y, again, this one's going to be greater because our 5, our a, is not negative. So that means it's going to be above your y intercept. Oh, not sorry, y intercept. Your asymptote. So that should be 1. Do our t-table to graph. We're going to have our x and our y is equal to 5e to the x. And we're going to use those vertical and horizontal shifts after we get these points. So we have 0 and 1. We have 5e to the 0, which is just going to be 5. We're going to have 5e to the 1, which is 5 times 2.71, which I got to be 14.55. So you get 14.55 if you use 2.71, but if you type this in the calculator like it is, you're probably going to get 14.59. So it's going to be a little different just because of the way the calculator is running and what number we use to round. So it does matter, but since I stated that E is approximately 2.71, that's what we're going to be using. So if you use a calculator and you type in the 5e to the 1 power, you're going to probably get 14.59 as your closest approximation. Once we have that, we're going to have our x and y, and on this one, we're going to add a 3 and subtract it, add a 1. So when we do that, we're going to have 3 plus 0 is 3, and 5 plus 1 is 6. 3 plus 1 is 4, and 1 plus 13.59. Sorry, this should have been 13.59, not 55. And the next one, plus 1, it should be 14.55. So when we do that, we're going to get 3 and 6. So 3 and 6. 4 and 14. So 10, 11, 12, 13, 14. So somewhere around here will be our graph. And can't draw a straight line. It should be something like that. Similar. So right here, these problems basically is asking us to use our properties of exponents to show or prove that they're equal to each other. So what I'm going to do, or what we should be doing, is manipulating our powers. So we know that when we see a 4, that a 4 we could write as 2 squared. So what I'm going to do is write this now as f of x is equal to 2 to the second power. And that x plus 1 is still part of our exponents. So we have that. And to simplify it, we're going to have f of x is equal to, and we're going to distribute that 2. And we're going to have 2x plus 2. So now you notice that g of x and f of x are equal to each other. So f of x is the same as g of x because they're the same exponential expression. So for the next one, part B, we're going to try to show that we can manipulate f of x equals 8x minus 2 and see if we could make that look like h of x and g of x. So the first one that I'm going to try to do, I'm going to try to show that f of x is equal to h of x by changing that 8. So we know that if we could write 8 as 2 cubed, and then we have what was left over, so we still have the x minus 2 that was originally there. So because this 2 to the third power, that's this 8. We are going to distribute that 3 to both everything inside the exponent or the parentheses, and we're going to have 3x minus 6. That's f of x. Well, we're very close to being the same. We have a 2 to a 3x minus, but this is a 5 and we got a 6. So that means these are not equivalent. Very close, but not equivalent. So now we know that f of x does not equal h of x. Not the same. okay? So I'm going to do that again, and I'm going to try to manipulate f of x. So I'm going to use my f of x function again, this one right here. And I'm going to see if I can manipulate it and make it look like g of x. So the first thing that I'm going to do, I can use my properties of exponents and separate this as two separate powers. So I could have 8 to the power of x times 8 to the negative 2. So I have an 8x and I have an 8x there. So I'm going to see if there's a way I could make that 8 to the negative 2 into the 1 over 64. So I'm just going to flip it around, and we know that that would be 8 squared, because if you have a negative exponent right here, you could, if you bring everything to the denominator, then you're going to have your power. So then have 8 to the x. We're going to simplify that, and we get f of x is equal to 1 over 64 times 8 to the x. And that tells me that f of x is equal to g of x, because they're the same function. So these three questions are basically one of each of the examples of the formulas that we're using. Honestly, it's a very easy process. All you have to identify is what you're given, and then substitute it in there. And you can use your calculator to do that. So you said that deposited $2,900. That is your principal. That's your P. In an account that pays 3.5%. Well, that means that's your rate, and you have to write that rate as a decimal. So that would be 0.35. Annual interest. It says find the balance after 5 years. That would be T, your time. So, and since we're using, it says if the interest is compound continuously, and compound continuously would be your formula for A is equal to P, R, and T, so per. So if we substitute that in there, we're going to get 2,900 E 0.035 times the 5, and you put that in your calculator, and you should get that it's approximately 3,454 with 61 cents. That should be your answer. So for the next one, again, our P would be the 2,900. This would be our rate, and again, it would be as a decimal, 0.35 is our annual interest, and it says find the balance after 5 years. Again, that is our time, that's our T, but now we want to do compound monthly. So our compound monthly formula would be the A is equal to P1 plus R over N and T. And our N, this would be, because it says monthly, we know there are 12 months in a year, so our N would be 12. So if we substitute that in there, we would have 2,900, 1 plus our 0.035 over 12, 12 times 5, which you know that is 60. I just put this in the calculator, in my graphing calculator, and it gives me the answer. And I get that it's approximately 3,453 with 73 cents. So for this one, we have the balance in savings account is 2,900. So this is what you have in your account. That's basically your A, what you have in the account. And this again is going to be your rate as 0.35. It says find the initial principal. So we're trying to find our P. So we're trying to find our P, and the account and the interest is a compound continuously after 5 years. That is our T. So that means we're using A is equal to per the PERT. We know that A is 2,900. Our P is what we're trying to find, and we have our E. Our R is 0.035 and times 5. We divide both sides by that. That goes away. We're going to find our P, and when we substitute that or plug that into the calculator, it should give us a 2,434 with 43 cents if we put this in the calculator. And again, each calculator is different. I'm using the Big Graphing Texas TI 84 Plus, and that one As long as I use appropriate parentheses, it allows me to do it. There's some other calculators that are a little, you have to figure out what to do. If you're using the TI-30 XIS2, I think that one you have to do like each step. So you would have to multiply the decimals, then do the E part, and once you get that, you would get times the 2900. So each calculator is different. So make sure you don't get confused.